Okay, children. Projectile, we want to discuss projectile. What is a projectile? Any body thrown with an initial velocity. For example, a stone thrown with a velocity, a ball thrown, or a cricket ball, a football, and a bullet fired from a gun, then moving train, if something is dropped, that all these are having some initial velocity, and after that it move under the effect of gravity alone, nothing else. Okay, such a body is known as a projectile, and we have to study the motion of projectile. What is the path of the projectile? Path of the projectile is a parabola. It move like a parabolic path. We have to prove that is a parabolic path, and we have to study how much distance a body move horizontally, how much distance is moved vertically, how much distance it will, how high it will go. That is vertical height, and how much distance it move along the horizontal direction. Horizontal range. What is horizontal range? What is the vertical height, maximum height it reaches? And also time of flight also. Time of flight means how much time it remain in air. How much time the body remain in air before it hit the ground. So time of flight. All these things we have to derive. So what all things we have to derive, children? Time of flight, horizontal range, and vertical height, maximum height. These three derivations we have to do, and we have to do problem mainly. This is for your exam, mainly problems. Derivation no need to study by heart, children. Okay, so then one more thing, we have to show path of the projectile is a parabola. That also we should show. Path of the projectile, it move along a parabolic path. That also we have to prove. Path of the projectile is a parabola. Okay. So I can explain that. I will share the screen. Understood? I will ask. Let me ask. What is a projectile? What is a projectile? ആരാണ് ചോദിക്കുക? ആദിനാഥ് എക്സാമ്പിൾ പറഞ്ഞ വാട്ട് ഇസ് എ പ്രൊജക്ടൈൽ? ഗീവ് എക്സാമ്പിൾ. ആദിനാഥ് ഒന്നും മിണ്ടുന്നില്ല. ആയുഷ് അല്ല, തുടക്കം പറഞ്ഞത് തന്നെ മിണ്ടാണ്ടിരിക്കുകയാണ്. ധനീഷ്.
Yes, teacher.
Give an example for projectile. Simplest
Throwing a ball.
Ball? Throwing a ball. Okay, good. Another example?
Dropping a stone from a moving train.
Moving train. Very good. Okay. And it move under the effect of? Body move under the effect of?
Gravity.
Very good. So that is a projectile. Any body projected with an initial velocity and it move under the effect of gravity. That's a projectile, children. So we can share the screen, how it moves, how much distance it move, high, all those things we have to derive, and some other factors also we have to discuss. Okay, I will share the screen for that. Net slow. By that time I will take the page. Two participants waiting. 35. Okay, children, here you can see
as vector A
okay.
equal to minus G into J cap. Why it is written as minus G into J cap? G is acceleration due to gravity, because we said once the projectile has been projected,
Net is slow, children. That's right. Okay, I will explain with this here, children. Projectile motion. Here, from here the body is projected. From here, x-axis and y-axis, and this is the origin. Net slow. ഇച്ചിരൊന്നല്ല വരുന്നത് വേണ്ട I discuss our notes. That's better. Okay, children, we will discuss the notes. An object that is in flight after being thrown or projected is called a projectile. Such a projectile may be a football, a cricket ball, or any other object. I have explained that. Motion of a projectile is the result of two separate simultaneously occurring components of motion. That I will explain. Simultaneously occurring components. That I will explain. Here we can see the black line represents the motion of the body, projectile, motion of the projectile, that black curve. Along this curve, the stone thrown is moving along this curve. Okay, and here the see from it start from O. O is the origin. Origin, how will you represent x coordinate 0, y coordinate 0? Origin represented by 0, 0. And from origin, the body is thrown with an initial velocity v0. It is represented v0. See how to represent initial velocity? Drawing a tangent. So at this point, what is the initial velocity? We just draw a tangent, red line. That's the tangent drawn at this point. Tangent drawn at this point, at initial stage, a tangent is drawn. That is representing initial velocity. See, all of you listen what I am telling. Listen very well. And after explanation, I will ask questions. So you should answer it. Okay. So from where it is thrown? From O, origin. And with what velocity is thrown? v0. Initial velocity is v0. How is it represented? Drawing a tangent at that point, red line. That is the tangent drawn. So vector OC, vector v0 is the initial velocity of the object. Then when it moves, see, it is having two components. We just now studied the velocity is having two components. Acceleration is having two components when body move in a plane. So here we have to take the components. So the here this you complete the parallelogram to take the components. You see this is the vector v0. Draw perpendiculars to both the axes where the perpendiculars meet. Here at the point D, the perpendicular is meeting on x-axis. So this is the one component of this velocity vector v0. So adjacent to this angle theta, what you are getting, this adjacent side. So that is cos component, v0 cos theta. And that we can also find cos theta. You just to find the angle of projection is theta here. With an angle theta with 40 degree, 30 degree, like that. It is projected. That is the angle of projection. Angle of projection. So Here, cos theta, take cos theta. Cos theta is adjacent side OD by hypotenuse, OD by V0. So, OD by V0 is cos theta. So, OD equal to V0 cos theta. That is how we write here. OD equal to V0 cos theta. Similarly, this vector OE, we can represent here. We can just move that vector parallel to it and keep it here. Now, this is component CD. So, you just find sine theta of this. Sine theta is opposite side by hypotenuse. What is opposite side? CD. CD by hypotenuse. Hypotenuse magnitude V0. CD by V0 sine theta. So, CD equal to V0 sine theta. CD and OE are parallel. So, we can write this component is V0 sine theta. So, I will tell once more, children, then only I will ask question. Okay, listen. So, you can see a body is projected from point O. Its position is 0, 0, x 0, y 0. Then it is projected with a velocity v0. One important thing. It is projected with an angle theta. Textbook theta 0 എന്നാണ് കൊടുത്തിരിക്കുന്നത് കേട്ടോ. തീറ്റ എടുക്കാൻ കുഴപ്പമില്ല, കൺഫ്യൂഷൻ ആവണ്ട. Theta 0 or theta you can take, children. Okay, then it moves. Under the effect of gravity, it is moving. Velocity, you know, when it moves, it will have two components, I told you. Initially itself, initial velocity is v0. It is represented by drawing the tangent at the initial point. Draw a tangent that will represent initial velocity, and we are taking the components of that velocity along the x direction and along the y direction. For that, what is to be done? Draw perpendiculars to both the axes. Where the perpendiculars meet, that will be the component. Here, when it see this perpendicular down to the x-axis meeting at the point D. So, you put a vector symbol here. That OD is the component of this velocity along the x direction, v0 cos theta. What is the component of this velocity along the y direction? It is v0 sin theta. Now, initial stage, initial velocity is v0 and its component along the x direction is v0 cos theta. Component along y direction is v0 sin theta. Similarly, take another point P here on its, this is the path. Path of the projectile is a parabola. Take another point, this is initial point. Take another point at another time t, body reached here at this point P. Its coordinates will not be 0, 0 now. For example, suppose it moved 2 centimeter on the x-axis and 5 centimeter on y-axis. 2, 5 we have to write. 2, 5 we have to write. X and y coordinate is different now. So, here we have taken just x and y only. X and y. It reached after a time t, body is at P. Its coordinates are x and y. And here also you draw a tangent here. Draw a tangent in the direction of motion that will represent the velocity there. And it also will have two components, that is x component and y component. Here also you see topmost point, velocity decrease. Which velocity is decreasing? Vertical component of velocity only decreasing. v0 sin theta only decreases. v0 sin theta, v equal to u plus at. So, final velocity here, when body reaches here, final velocity v equal to v0 sin theta minus gt. V equal to what we have studied till the final velocity v equal to v0 plus at. We have studied v0 plus at, initial velocity. But here two components are there, v0 sin theta, v0 cos theta. And v0 sin theta component, that is vertical component of velocity, decreases by the factor gt, minus gt, like that it comes. And when it reaches the topmost point, children, final velocity becomes 0. Vertical component of velocity is 0. It is having only the horizontal component, v0 cos theta. And you can see that green color we used to represent the horizontal component. Horizontal component is represented with this green line. So horizontal component during its motion, it is not at all changing. Do you know the reason? Vertical component is changing by the factor. When it move upward, V0 sin theta minus gt. When it come downward, it becomes V0 sin theta plus gt. When it move upward, we have to take velocities decreasing, becomes 0. When it come downwards, increase and increases to the maximum value. When it touches the ground, it will have the maximum value. Okay. Now I have told many things. I don't know whether you got it. I will ask question, children. Then only I can make sure whether you understood or not. So here, at what position body is projected, children? I'll ask to Danush. At what point body is projected? Danush. ചെറിയൊരു ക്വസ്റ്റ്യൻ ചോദിച്ചിട്ട് അതുപോലെ ആൻസർ ചെയ്യാൻ പറ്റില്ല. Hemal Krishna. At what point body is projected?
0.
0. Okay. With what velocity it is projected?
V0.
V0, initial velocity. Very good. Which are the two components of initial velocity V0? Two components along the x direction. This one along
V0
the
cos
cos
theta.
theta. Along the y direction.
V0 sin theta.
Very good. Now we got the component. Okay. So with these two components, the body is moving, and when it move upward, one component of velocity decreases. Jaitar, can you tell which component of velocity is decreasing, vertical or horizontal? Jaitar? Midul? Nidal? Rahan? Which component? Vertical component of velocity or horizontal component of velocity? Which is decreasing? Nihal? Nihal oda poi? Nihal, which component of velocity is decreasing? Vertical or horizontal?
Vertical.
Vertical. Vertical is decreasing by how much? Look here.
GT.
By minus gt, decreases. G, time അനുസരിച്ച് വന്ന് at the topmost point, vertical component of velocity becomes?
Postage.
How much? How much vertical component of velocity become at topmost point? ഒരു ബോഡി എറിഞ്ഞു കഴിഞ്ഞാൽ ടോപ്പ് മോസ്റ്റ് പോയിന്റിൽ എത്തുമ്പോൾ അതിന്റെ വെലോസിറ്റിക്ക് എന്ത് സംഭവിക്കുന്ന പറഞ്ഞു തന്നിട്ടുള്ള ടോപ്പ് മോസ്റ്റ് പോയിന്റിൽ എന്താ സംഭവിക്കണേ? പിന്നെ എന്തുകൊണ്ടാണ് ആ ബോഡി മുകളിലേക്ക് പോവാത്തത്? എന്തുകൊണ്ടാണ് ഇവിടെ വെച്ച് നിന്നത്? അവിടെ നിന്നിട്ടാണല്ലോ താഴ്ത്തിക്ക് വരുന്നത്. വൈ പാർവതി? What is the vertical component of velocity? Topmost point. Parvati?
Velocity is equal to cos theta?
Vertical component of velocity V0 sin theta decreases and it reaches the topmost point. It becomes? 0. 0. But it will have horizontal component of velocity. V0 cos theta is not changing. Why? Because there is no acceleration in that direction. Horizontally there is no acceleration. Only gravity is acting. It is acting downward, pulling it downward. Gravity is acting. Along the horizontal direction, nothing else is there. See, nothing, no acceleration. So the horizontal component of velocity V0 cos theta remains same. Vertical component of velocity decrease 0, increase and reaches the maximum. That is happening. So which component of velocity is decreasing? Vertical component of velocity. When it reaches the topmost point, vertical component of velocity is?
0.
But still it will have horizontal component of velocity. What is it?
V0 cos
Cos
theta.
theta, very good. So V0 cos, that is what I told. V0 cos theta during its motion, throughout the motion, V0 cos theta is not at all changing. That everywhere you can take, draw tangent, represent velocity, take the components, we can see V0 cos theta remains same. But V0 sin theta first decreases, becomes 0, then increases. V0 sin theta plus gt, V0 sin time, depending on the time, the velocity is increasing. V0, see V0 for sin theta, this component, V0 sin theta component decrease, 0. Then increase and reaches the maximum. When it reaches the, then it just touches the, just before it touches the ground, it will have maximum velocity. Okay, so that is the projectile motion important factors when you study important factors. Okay, and I'll ask to Parthiv, what is the vertical component of velocity at the topmost point? Parthiv. Sriram, what is the vertical component of velocity at the topmost point? Sriram?
It will be 0.
0. Very good. What is the horizontal component of velocity at the topmost point?
V0 cos theta.
Okay, very good. So that is the important factor that you should know. Then we can find out how much height it will go. That means this height. When a body is projected with an angle theta, how high that body go? If it is having an initial velocity v0, those things we can derive. Similarly, how much distance horizontally, how much distance this is vertical height. How much vertical height it will attain? How much horizontal distance it move? And also one more thing, that is time, how much remain it in the air, how much time it remain in the air. All those things we can derive, very important problems also. We can see only these things are needed to derive that. Okay, we can discuss. Path of the projectile is a parabola. We have to prove that path of the projectile is a parabola. Even though derivation will not come, you should know the concept. Concept must be clear. Okay, children? See. The same figure is drawn here. See, when the body move along the x direction, when the body, we have to take the component x, horizontal distance. Suppose we want to find the horizontal distance, we use the x component. Suppose we want to find the vertical height, we use the y equation, y equal to y0 plus v0 y into t plus half a y into t square. How much distance it travel or cover along horizontal direction, we have to use this equation, x equal to x0 plus v0 x into t plus half ax into t square. Okay. So that equation, when you take x equal to x0 plus v0 x into t plus half ax into t square, when you take that, we get like this. X equal to x0, initial position is 0, 0. So x0 is 0. x0 plus v0 x, initial velocity is x component, v0 cos theta into t plus half at square. A is 0. Horizontally there is no acceleration. So a is taken 0 into t square. So this term vanish. This term will not be there. Only this term will be there. X equal to v0 cos theta into t. See children, horizontally the velocity is v0 cos theta. Horizontal distance in a time t. How much distance it travel? There is no acceleration. This is the equation for uniform velocity. X equal to v0 cos theta, velocity into time. What is the horizontal component of velocity? V0 cos theta. V0 cos theta into time. So x equal to V0 cos theta into time, or t equal to x by V0 cos theta. We got the equation for time, and that is substituted in the equation for y. Y equal to, I will show this, y equation for y equal to y0 plus v0 y into t plus half a y into t square. Here y0 is 0. We know initial position we represent by 0, 0. So y0 is 0. V0 y is v0 sin theta, vertical component of velocity v0 sin theta. And acceleration we take when the body is moving upward, acceleration due to gravity we take minus g. And substituting all the values, we can write y equal to 0 plus v0 sin theta into t plus half into acceleration due to gravity minus g. We taken minus g into t square. Then t, in the place of t, we substitute this value. In the place of t, we substitute that value. So x by v0 cos theta is substituted. X by v0 cos theta is substituted. Then minus half into g, t square. T square is x square by v0 square cos square theta. Then v0 cancel. We get x tan theta minus half into g by v0 square cos square theta into x square. So this equation is in the form of y equal to ax plus b. A is a constant. And b, yx plus bx square. Ax plus bx square. You might have heard that equation for a parabola. Y equal to mx plus c, equation for a straight line. Y equal to ax plus bx square, it is the equation for parabola. So now this equation is in the form of a parabola. Parabola equation is this. When you plot a graph between this y and x with this equation, we get a parabola. So this is the equation for a parabola. Equation for a parabola, children. So here this is the proof for showing that path of the projectile is a parabola. So first what is taken? X equation is taken. From that t is found out. And that t is substituted in y equation. And we can show that the path of the projectile is a parabola. That's all we have done. Derivation, no need to study by heart, only to understand the concept. Okay. Derivations will not come for exam. Concept should be clear. Next, time of flight you are going to calculate. Time of flight. Better than I will show the figure. Again, figure is needed. See, this is the motion of the projectile. We are going to find time of ascent. Time of ascent means how much time it takes to reach the highest point. What all things we are having, children? We are having angle of projection theta. We are having velocity, initial velocity v0, and we know the component of velocity along the x direction and y direction. And after a time t, suppose this is the highest point, h is the highest point, and we are calculating the time taken by it to reach the highest point. We are having the initial velocity, we are having the original position, we are having the angle of projection. That only we are having. But we have to calculate the time of ascent. Ascent എന്ന് പറഞ്ഞാൽ എന്താണ്? To rise to the highest point. How much time it takes to ascend to the highest point. Velocity. What is the final velocity here? Final vertical component of velocity, children? Final vertical component of velocity?
0.
0. So, when we consider this vertical direction motion, vertical component only we have to take. So, final velocity is vertical component. What is the equation? Velocity time relation? Devi Krishna, what is the velocity time relation? Devi Krishna, velocity time relation. V equal to Devi Krishna illalo. Aishwarya, yes, what is the equation? Velocity time relation. V equal to, please tell. Deeba, tell what is the velocity time relation? Deeba. Velocity time relation. Velocity time relation, tell. V equal to Devatirtha. Devatirtha. Chandana, tell what is the velocity time relation? Chandana.
V is equal to plus 80.
V equal to U plus 80 അല്ലെങ്കിൽ V0 plus 80. Y component പറഞ്ഞ അതിൻ്റെ Y component. Vy equal to Vy equal to
V0
Y
y plus
y into t. Very good. Y into t. Okay. That equation is used to find the time taken to reach the highest point. Highest point, final velocity we can take 0. Okay, children. Initial velocity V0 and vertical component of velocity we have to take V0 sin theta. So, vertical component of velocity V0 sin theta, initial velocity V equal to V0 y minus gt. V0 y minus gt. Okay, that formula is used. I will show the steps. Time of flight. Time of flight. See. Vy equal to V0 y plus y into t. This equation we have to take to find the time of ascent. You know, time of ascent will be same as time of descent. How much time it take to reach the highest point? The same time it will take to reach the ground at the same level. Same level, that's important. To reach at the same level, it will take the same time. So, time of ascent is same as time of descent. Time of ascent is same as time of descent. So, if you know time of ascent, double it, that will be the total time taken to reach the ground at the same level. So, now we are going to calculate the time of ascent, children. So, t is taken from this equation. Substitute Vy, final velocity of the y component is 0. 0 is substituted here plus initial velocity is y component V0 sin theta minus g into capital T by 2. Capital T by 2 because or small t you can write, then you will get time of ascent. But here they are calculating the time of flight. Total time is calculated. Time of flight is calculated. That is time of ascent plus time of descent. Suppose you are calculating the time of ascent only, you have to write small t here, small t. Then we will get small t there. But here, then double it. That will also give the time of flight. Total time of flight you will get. First find out small t, then double it. That is done here. See, doubling it. Time of ascent equal to time of descent equal to small t. Therefore, total time of flight equal to time of ascent plus time of descent. That's equal to small t plus small t 2t. Or small t can be written as capital T by 2. And that is substituted here. Capital T by 2 is substituted here. Okay, children. And g into capital. In the place of time, we write capital T by 2. Time of ascent. Capital T, total time. Time of ascent plus time of descent. Total time by 2. That is our time needed. Okay. So, V0 sin theta equal to gt by 2. Therefore, t equal to 2 V0 sin theta by g. one expression we got, time of flight. Okay, last question, and then I will take that sentence. Okay, children. Time of what is the relation between time of ascent and time of descent? Bhagat?
Teacher,
What is the relation? Are they equal or different?
they are both are equal.
Both are equal, correct. Okay. What is meant by time of flight? I will ask to another one. What is, Gayatri, what is meant by time of flight? Time of ascending? Gayatri?
Plus time of descent.
Time of ascent plus time of descent. That is the total time of flight. Okay, very good. So we got we have calculate to calculate the time of flight. Which formula we use? Nandana, which formula we use to calculate the time of flight? Which formula we use? Nayana, which formula we use?
Equal to u plus 8.
V equal to u plus 80, correct. And its y component we have to use. Y component. Okay. Vy equal to v0 y plus ay into t. T is taken as total time of flight by 2, and then capital T is calculated from it. You always remember this formula, very important. Whenever I ask this, you must know what is time of flight. 2v0 sin theta by g. Okay, children. The other two derivation we can discuss tomorrow's class. Let me